Dear students, welcome to the today's class. I am Manaka Devi, Assistant Professor, Department of Electronics and Communication Engineering, HiSET. Today's class we are going to discuss about the topic wired LANs, Ethernet. So these are all the contents of the today's class: Ethernet protocol, Ethernet evaluation, Ethernet addressing. Ethernet protocol. So Ethernet is nothing but it is the one of the most widely used LAN technology. So data link layer and the physical layer are the territory of the local and wide area networks. This means that when we discuss these two layers, we are talking about networks that are using them. So Ethernet is based on the IEEE Project 802. In 1985, the Computer Society of the IEEE started a project called Project 802 to set standards to enable intercommunication among equipment from a variety of manufacturers. Project 802 does not seek to replace any part of the OSI model or TCP/IP protocol should. Instead, it is a way of specifying functions of the physical layer and the data link layer of major LAN protocols. The relationship of the 802 standard to this TCP/IP protocol should is shown in figure. IEEE standard for LANs. So the left side, this one is OSI or TCP IP protocol should. This one is IEEE standard Ethernet. Here in both the sides, the physical layer is same. In the TCP IP protocol suite, the second layer is data link layer. In the IEEE standard, the second layer is divided into two groups. One is LLC, logical link control, and the second one is MAC, media access control. The logical link control and medium access control in IEEE Project 802, flow control, error control, and part of the framing duties are collected into one sublayer. That layer is called LLC, logical link control. So LLC provide one single data link control for all IEEE LANs. IEEE Project 802 has created a sublayer that defines the specific access method for each LAN. In contrast to the LLC MAC, contains a number of distinct modules. Each defines the access method and the framing format specific to the corresponding LAN protocol. For example, CSMECD, Carrier Sense Multiple Access Collision Reduction, a media access method for Ethernet LANs, and token passing method for token ring and token bus LANs. Framing is handled in both the LLC and MAC sublayer. And the next one is Ethernet evolution. So Ethernet evolution is divided into four broad categories. First one is standard Ethernet. It supports for 10 megabits per second. And the next one is fast Ethernet. It supports 100 megabits per second. And the next one is gigabit Ethernet. It supports 1 Gbps. And the next one is 10 gigabit Ethernet. It supports for 10 Gbps. The next one is Ethernet frame. So this is the frame format of the IEEE 802 standard. The first field is preamble. So preamble is nothing but it contains 7 bytes of data. Here the datas are alternating ones and zeros. And the second field is SFD, start frame delimiter flag, which is a 1 byte. And the next one is destination address. This is a 6 byte. And the next one is source address. This is also 6 bytes. And the next one is type. This is a 2 bytes. And next one is data and padding. Here the minimum data length is 46 bytes and the maximum data length is 1500 bytes. And the last field in the frame format, CRC, cyclic redundancy check. It is a 4 bytes. So this is the physical layer and this is the physical layer header, and here to here this is the IEEE 802 standard frame format. And the next one is addressing. Each station on the internet network, such as PC, workstation, or printer, has its own network interface card. We can call it as a NIC card. The NIC fits inside the station and provides the station with a link layer address. The Ethernet addresses is 6 bytes, nothing but 48 bits, normally written in hexadecimal notation with a colon between the bytes. For example, the following shows a Ethernet MAC address 4830. So 48 colon 30 colon 10 colon 21 colon 10 colon 1A. So this is the another problem. Define the type of the following destination address. So 48, based on this first address, we can define which type of data. So to find the type of address, we need to look at the second hexadecimal digit from the left. If it is a even, the address is a unicast. If it is a odd, the address is a multicast. If all digits are F, the address is broadcast. Therefore, we have the following 4A. In 4A, the second one, here the A is nothing but in the binary format 1010. So it contains even number of ones. So it is a unicast address. And the next one is 7. Second problem, second digit is 7. 7 is represented as 0, 1, 1, 1. It's a binary format. So it contains odd number of ones. So it is a multicast address. And the next one is F. F. So F, all the digits are F is hexadecimal. So it is a broadcast address. Thank you, students.